Hey guys, welcome back. I'm going to go over the problems at the end of the egg catcher packet in case you guys need any extra help on those. And again, you were supposed to skip a few of them. So those we won't be going over. Four, 6, and 11. All right, so a 75 kilogram cart that's traveling at a constant speed has a force applied to it, which brings the cart to a stop in 15 seconds. A force first time graph of this event is shown to the right. What was the impulse delivered to the car? The impulse is going to be the area. And so I have a triangle, a rectangle, and a triangle. So I have three different shapes here. And so this gave me 1,500. And they have the answers on there, but I'm going to want to see your work. What speed was the car moving when it was hit? So we could say so I could take the impulse that I just solved for and divide it by the 75 kilograms, which gives me 20 meters per second. All right, number two, the motion of another cart if mass 25 kilograms is depicted in a momentum time graph. Determine the impulse delivered to the 40 kilogram cart. So this is the change in momentum. So the momentum changed from 40 to 100. That would be a change of 60. What overall force acted on the car? So again, F is going to be equal to the change in momentum over time. Our graph tells us that this is 60 kilograms meters per second in 2 seconds. So that's 30 newtons. And then part C, what was the change in velocity of the car? So this is also equal to m delta v. So I could take the 60 and divide it by 25 kilograms, which is 2.4 meters per second. Number three, a 3.8 kilogram object was accelerated from 12 meters per second to 19 meters per second by a force of 16 newtons. What impulse acted on the object? So again, impulse is our change in momentum. So I'd have to take the difference. So this is going to be 3.8 kilograms times the final speed, which is 19, minus 3.8 kilograms times the initial speed, which is 26.6 kilograms meters per second. How long did the force act? Again, this is also equal to F delta t. And so if I divide both sides by F, I would have delta P over F is T. So this is going to be 26.6 kilograms meters per second divided by the 16 that they give us, which was 1.7 seconds. All right, I'm going to scroll this up a little bit and make some room for myself to do the next one. And maybe take a sip of agua. A sandbag stops a 0.012 kilogram bullet, which was traveling at 860 meters per second. The bullet penetrated a distance of 0.24. Oh, that's a skip one. A smallish physics student of mass 36 kilograms slides across a smooth ice at 6.8 meters per second. She then slides into rough ice for 2.4 seconds, changing her velocity to 2.2 meters per second. What is the momentum of the student as she slides across the smooth ice? So her original momentum would just be her mass times the velocity. So this is going to be 36 times 6.8. And that is going to be 244.8 kilograms meters per second. What is the size and the direction of the force acting on the student after hitting the rough ice? So they're telling us that she has are they telling us that? They're not telling us that that's her velocity. It could be her speed. The force has to be in the opposite direction, right? So the force has to be oppose her. We can get it by taking the change in momentum is equal to force times time. So F is going to be equal to M delta V over delta T. And so her mass doesn't change, but her speed changes from 6.8 to 2.2. So I should have final minus initial, right? So I should have 2.2 minus 6.8. And we're saying this happens in 2.4 seconds. So it's negative 69. It's going to be in the opposite direction. All right, 6 was a skip. Let's go on to 7. A 60-gram bullet is fired from a 5-kilogram gun with the speed of 600 meters per second. Find the gun's recoil speed. This is going to be a conservation of momentum problem. We're going to start off with a momentum of 0. And so I'm going to know that this initial momentum is going to be equal to my final momentum, and they have individual momentums right? The bullet's going to go one way, the gun's going to go the other way. When I add those together, I'm going to get 0. So this is 0 equals M1V1 plus M2V2. So it's going to be minus M1V1 equals M2V2. And then I'm going to divide both sides by M2. So I have 0.06 kilograms. The bullet's the same mass as our egg. Who would have known? And this bullet's going at 600. My gun is 5 kilograms. So it looks like I'm going 7.2 meters per second in the opposite direction.